All right, it is 1 o'clock Pacific Daylight Time, and since we have a pretty full agenda today, let's get started. This is the AVT Core meeting at IETF 117. Thank you all for being here. Next slide, Bernard. Meeting tips. You can, so please make sure to join the Meetico if you're on site. If you're off site, you already have if you're hearing this. Unless you're using the audio stream, but probably you should anyway. So yeah, there's use the you can either use the full client or the light client as you like. There is a QR code to join it, or you can do it from the agenda. You got a copy of the QR code up here. If you're using the full version of the client on site, please mute the audio locally. There's a button down in the lower right to do that. Otherwise, we'll get weird feedback noises. Use Meetico to join the mic queue. Remote people, please make sure you're not sending audio or video unless you're actually talking. And use of a headset is strongly recommended so we don't get feedback or echo. All right, remote meeting tools. You have to press the hand to join the queue. You have to press the microphone to be heard. You can also press the camera icon to be seen, but you have to do that separately from being heard. Video is not required, but it can be helpful if for comprehension. Next slide. Here are some links. Hopefully, generally about the IETF. Next slide. About this meeting. We have a link to the agenda. If you want to take notes in the note-taking tool, there's a link, there's a URL there. I'm the chair on site. Bernard is remote. I'm listed as both, I guess a error in the slides. I will also be keeping an eye on the chat. And Stefan Wenger has volunteered to be a note taker, but if anybody else wants to take notes also, that would be appreciated. Because it's good to have backup in case he gets, he's actually saying something, because he is presenting in one of the sessions. So hopefully he can remember what happened when he's presenting. But especially for that, go ahead.
Additional takers.
Nobody's volunteered yet to be an additional note taker, but just as backup in case Stefan misses something. Oh yeah, drops. Hopefully, I think if Stefan drops dead, I think we're pausing the meeting to call, the appropriate authorities. Let's see, who can I impose on? Let's see. Well, we'll just continue, and then hopefully we'll all remember what happened, and if not, we have the recordings. Note well, this is various IETF policies about privacy policy and IPR policy and code of conduct and anti-harassment and the like. Please be aware of these. Hopefully you've seen these if you're here, but please be aware of these. Next slide. In particular, we want to reinforce that we have the code of conduct and anti-harassment policy. So remember, treat everybody with this dignity, decency, and respect. Adhere to professional standards. If you feel like there's been any violations of this, please contact somebody on the Ombuds team. Next. Here's our agenda. It's fairly full, so we'll try to get through things relatively quickly. I am going to try to use the countdown timer tool this time so that we make sure that we stay on schedule. But hopefully we can get through things with reasonable expedition. One change from the originally published one, I'm not sure actually what the order is of these two. I think it's this slide disagrees with what we have on the tool. So we have added the Martin Siemens presentation about using Quick to traverse NATs because it's related to Peter Thatcher's. This was also presented very quickly and quick, I guess yesterday. So since those are sort of covered in the same area, we thought to talk about them, even though I'm not quite sure this is the right working group for either of them, but it's a venue. All right, next. Here's our draft status. Had several things published. We have Skip and AD follow-up, which we'll be talking about briefly today. And frame marking, a draft was published 10 minutes before the meeting. So it is no longer revised ID needed. It is whatever the state is where the ADs look at that and see if whether it resolved their comments. So, all right, and these are our adopted drafts. I think we're talking about all of these today. Next, and EBC, so Stefan.
Yeah, so I'll cover some of these with comment from Stefan.
Do you do that, please?
Okay.
Yeah. So,
okay.
So I've been writing up the publication request, and so this is a kind of a summary of where things stand. I just posted it to the list on July 22nd, my draft. That includes a pointer to the summary of working group last call. And so I should just ask the question here, are there any working group concerns or issues that have not been raised in that working group last call that someone wants to bring up now? Because in my pub rec, I basically said I thought this draft had remarkably little disagreement and there was consensus to proceed. Does anybody wish to object or to raise something else? Okay. All right. So the other thing that's in the pub rec request is implementation experience. Just wanted to get an update if there is any. Stefan mentioned that Tencent had implemented the EBC payload, but not the STP, and there hadn't been any interop testing. Is there any other implementation experience aside from that?
I don't see anybody queuing up.
Or is there? Do you want to? Okay, you're not commenting on that. Okay.
No, I was just saying I don't see anybody queuing up, so we can probably go on to your next one.
And then we asked for the author confirmations, which we got on the list. First was assent to being an author and a contributor, and we did get the authors and contributors say that was okay, and then the BCP 78 79 conformance, and they responded affirmatively to that. Media types review, Stefan requested that review on March 29th, and got a review by Ronnie Evan on April 3rd. And other than recommending the IETF AVTCORE working group as change control, he didn't find any issues in it. I have reviewed it. It's very, very similar to the H266 IANA assignment. So I couldn't really find much to say about it because it's basically already there. I'm going to put all this into the pub rec, but I don't see there's a lot to talk about here unless somebody has any special observations about the media types or the IANA section. It's pretty straightforward. And so the remaining issue really to talk about here is IPR related. And that comes up because of what is in section 1 of the draft, which basically states that the EBC standard was published in 2020, and a goal of MPEG was to keep the baseline profile essentially royalty-free. But we have received an IPR declaration on this draft. So on June 16th, I sent a message to the working group requesting confirmation to proceed. And the document authors were interested in proceeding, the three of them, but nobody else responded. So I wanted to ask the working group, is there any objection to proceeding or any questions relating to IPR issues that you wish to discuss relating to EBC, RGP payload? Is there anything, Stefan, that you wish to say about this? Don't feel forced to, but if you want to.
I could answer questions, but I'm not volunteering information unless people ask questions.
Yeah. So let me put it this way: is there any objection to proceeding in spite of the IPR declaration? And if so, can you come to the mic and describe your objection? So can we put in the minutes that there were no objections? Is that a fair statement, Jonathan, given what you're seeing
Yeah,
in
I
the
think
room?
so. Yeah.
Okay.
Stefan, you hear that? Just put in the minutes that there's no objections. Yeah. Good, wonderful.
All right. I think that's it for EBC. Unless anybody has any other comments or questions. Thank you.
Okay, so next up is V3C.
Hello, can you hear me?
Yes, we can.
All right, perfect. Let's go ahead then. So the short update is that I made a draft version 2 available, and here's a link that describes the diff to the previous version. Heads up, it's a rather large diff, but in terms of the changes, it's not that big of a change. So we did a thorough review of the text. We updated the examples with real values. We clarified the normative versus informative parts. We improved the language of the spec on several occasions, and we added some text for the declarative SDP consideration as well as IANA consideration section. We did, however, introduce a minor technical change, and our thinking is that because this hasn't been implemented yet, it doesn't really change that much. So we just changed the null unit type for the fragmentation unit payload header from 58 to 57 to kind of keep a solid range without any empty values in between. Right, so 57 was previously used for temporal aggregation units, which we previously removed from the draft because it was believed to be too complicated. Next slide, please. So here on this slide, we basically just want to mention that we're working on an implementation that we're planning to make available by the November meeting. So this will be a GStreamer plugin that people can play around with. As always, more feedback on the spec is welcome. And yeah, you can provide the feedback through this GitHub page via issues, and you can do pull requests and all if you find something that you want to fix or change. And yeah, as discussed in the previous meeting, the specification is largely stable and mature. So we would like to propose moving to the next stage, i.e. proposing the last call.
Yes, I think in the absence of any known open issues with the spec, I think a last call is appropriate. So yeah, I guess Bernard and I will figure out between us who's going to handle that. And we will go ahead and if nobody has any objection, we'll go ahead and do that. Excellent.
Please note in the minutes that there's this request to go to last call. Get it on the action item list and not forget.
Good, thank you.
Sorry, Stefan here. Yes, I note this in the minutes. One thing is, in other working groups, there are shepherds who are not chairs. You guys are aware of that? I mean, you guys really load yourself up for no real reason, right?
Does that mean you're volunteering to be a shepherd, Stefan?
Yes, not for this draft, but yes.
Okay, cool. Good to know. Yeah, all right. Yeah, we may take advantage of that. That's a good idea. Thank you.
Yeah, well, thank you, Stefan. In particular, as you know, the bureaucracy has increased lately, so we appreciate your volunteering.
And anyone else who wants to shepherd any drafts, we would certainly just let us know and we'll help you out, or we will give you something you can work on. It's a good way to get, if you're new in the IETF, it's a good way to sort of get involved in the process and understand what's going on too. Okay, next up is Skip. So,
Oh, can you hear me?
yes, we can.
Yes.
Yes, this is Dan. Okay. Do a quick intro. Mike wants to speak a few words here as well. Again, our draft was published back on March 29th. We still have one outstanding discuss with soccer. Roman posted abstain on the 24th. He also just posted about 2 hours ago some additional comments to do that. And again, we're kind of looking at a way forward at this point. I know our time is brief. We got a lot of stuff to go through, so I'll let Mike speak.
Yeah. Oh.
Okay.
We also do have one of our ADs here.
Yeah, just on Zahed, he had to leave the meeting for family reasons, so it may be a few days before he gets back to you, but he is aware that this is waiting on him.
Okay. Yeah. Briefly, just I wanted to comment the fact that a lot of the issues that have been brought up at this level now are issues that were brought up during these meetings, and they're being rehashed with some desire to change the outcome of the previous. And we understand it to some degree that it's a different level, different people looking at it, but they apparently don't have a lot of background into the discussions we've had. And to some degree, some things that we fixed seem to still be floating around as being something they think they need to comment on. And it just is holding this back. And we're unsure how to get them to realize that some of their issues have been discussed or handled elsewhere, not in a specific section elsewhere in the document. It's like they read for their section for the thing to be changed and it wasn't there, so they can't find it anywhere else. And it is just delaying this document. And people sitting and not responding to emails for months doesn't help either. We have a community we're serving. We have fielded products in both military, commercial, even in the the educational environment, and SCIP is there, and it's an application layer protocol that simply needs a SCIP/8000 to make it through a network to function. The application will find a way to work over what the RTP connection is. And to some degree, it is up to the vendors of our SCIP products to follow the SCIP standards to make that work, and they will. But this is being delayed, whereas there's been other RFCs that have done similar things that have made it through.
Yeah, I would also mention that the principles of SCIP are now being adopted elsewhere because the principles of basically just declaring the end-to-end encryption in SDP are now being used elsewhere, such as in WebRTC. So this is not just a SCIP draft, it's a foundational draft for other elements of AVT core. So the lack of progress is affecting other things. And
to be honest, there's questions about whether or not they think this belongs in the IETF, and I just have to ask the question. Considering the IETF runs the internet, which everything uses, how is this not to be an IETF spec?
Yeah, I mean, in particular, the elements of the SDP negotiation described in the draft, as I've said, are happening elsewhere. So without a standard, those other things are looking at what's happening here, and they're just saying, hey, we're not even going to go to the IETF. We're just going to implement what SCIP did and just shove it, put it in the browser, as an example.
And if they can get away with that, good. But we're finding in the commercial OEM environment, a lot of people are filtering on the contents of the SDP, and SCIP won't make it through it. That's the purpose of this. The purpose of this is that we get a single document, we can approach the OEMs and say, this is what you need to do. Because without this, it's very difficult to give people, as you may realize, given our documents, even if both of you, I believe, have reviewed SCIP 210, it's a little difficult to understand what they're doing. This is a simplistic form of saying to a router manufacturer, an IPS system, session border controller, here's what you need to let get through.
Okay. Yeah. When for the
ahead.
for the soccer discuss, yes, a couple of slides down, I could talk about the issues that we've already addressed. I mean, this goes back to January of this year, referencing version 4 of our document. If you could advance 2 slides, I guess, ahead, or one slide, 2 slides ahead. I guess one more slide. There you go.
Oh, sorry.
Back
Hold
up
on.
one.
Hold on. Yeah, back up.
Right.
Okay. Yeah.
All right. Yeah. So there are a couple of things again that were brought up in soccer's discussion that we've already have been removed in version 5 about the variable bit rate and jitter buffer, things like that. Those are already gone. Those have already been resolved and no longer appear in the text. Same thing with the STP B parameter, bandwidth parameter. That text has also been removed, and the TSV art questions of basically nearly all those were already been applied in version 5. So was asking again, we've discussed this many times before about the most current skip document not being public domain. Again, we've provided those on request through NATO to provide the most current version. However, there is an old version you can still get on the US government website. It's listed there for people who really want to see it, who haven't requested specifically the latest version through NATO. So it is.
Just a clarification I'd like to make. What I saw in the ISG comments was actually interesting because it looked to me like a misunderstanding of IETF policy. IETF policy does not require any SDO to provide documents free of charge on a website. That is not the case. Many SDOs that the IETF works with, including IEEE 802, ISO, and others, don't do that. The requirement is merely that the document be provided to those who ask for it, which has been done in this case. Multiple participants have asked for and received the document. So as far as I can tell, the skip document is within the practice of any other SDO. And if the IETF were to require everything to be publicly on a website, we would be unable to reference IEEE 802 documents, for example. So I think I was kind of shocked to see some of the ISG comments that don't understand what the IETF policy is. So I just wanted to clarify that. And as you point out, it is available on the, older versions are available on the web, which for this purpose, I think, are quite adequate for describing the state machine, although they may not be precisely correct.
Murray?
I think the ISG is aware of what the policy is. What gives us trouble during evaluation is if we can't access the references that are being used. For example, if you're saying all the security properties of this thing are defined in that document over there, which you can't read, the security ADs have no way to evaluate this document.
Yeah.
So it's not that.
So as we've noted, first of all, it's available publicly on the web. So that's not the case. And secondly, it will be provided to anyone who asks for it, as is the case for IEEE 802. So the idea that it's not available is just not factually correct. And I want to correct that here. That's never been the case.
What you said, a bunch of things have been jumbled here. First of all, please don't interrupt me. Second thing is, the problem is that we couldn't get it when we wanted it during evaluation, or I don't know exactly what the problem was, but there was no assertion on our part that the policy is the document must be available freely to everyone, always. That's never been the rule, and the fact that this is under revision right now from us is meant to clarify that we know that that's the rule.
Yeah, there was never a request from the ISG for the document, so that didn't happen. And I think that can be confirmed by the authors. It was never requested. So, and if the ISG were to request a document, it would be provided. Is that not the case, Mike?
Yeah, well, I mean, the email address is right in our spec that tells readers where to go to request the specifications. What's right there in our documents.
I asked for it. I was provided with it. Others have in the working group have asked for it and have been provided with it. So, and it's available to the ISG if they were to ask for it. So just to clarify that, that's been the case all along.
And let me comment, please. one of the things that was done during this is someone complained that they asked for a document and they didn't get it within an hour. Their complaint was that they didn't get it, and that came out the next day. That's a little unrealistic for this community. I am sorry, they're not sitting there waiting for your call. It may take them time to do that, but that document is available to those who request it.
Stefan?
So I think this needs to be escalated a little bit, and this is a matter of principle thing. Yeah.
Right.
If we have a situation that the ISG cannot work on a document, it cannot work on an informative reference. No, cannot work on a document that includes an informative reference that is not, immediately available for download through the World Wide Web. Then we have really a very serious problem in this particular working group here, because the vast majority of our documents are not available like this, right? And it includes even normative references. So if that means we have an automatic delay of a few ISG meeting cycles for document approval based on this level of thing, that's sad. We can do a little bit here on our side by just preparing for the ISG a package, right, with this type of stuff, and then you guys will have to work a little bit on or in the future, right? For this document, I think we're fine, but we'll have to work a little bit on this request response protocol and just grab the document for the ISG with all these members, and the working group chairs have to do that on their behalf. But if that's what it takes, then that's what it takes. But it's still, I think it's unreasonable to require any informative reference in the first place, because the ISG in general is not part of the community who is interested in this stuff, right? People who are interested in this stuff have these documents at their fingertips, generally speaking. Thank you.
So what it
One
comes
more
down to
comment.
when a document comes to the ISG is, can I review this document? And if I'm not able to do my job, how am I supposed to ballot on it? I can't just sort of forgive that this whole area is undefined, especially if it's a normative reference. If it's an informative, I'm still facing the question, like, can I actually legitimately put a ballot on this document? Do I understand this work? Is it internally consistent with this other document? If I can't answer those questions, how am I supposed to do my job? So,
Well, yeah, the point is,
trustworthy.
it is available, and if the ISG would like to get a copy of it, it can. And if that's
Okay.
we can make it available. And the reason we raise this, Roman, it's very important, is because, as Stefan said, we have other documents coming in the same situation. For example, we have the EVC document, and ISO doesn't make that spec available, but Stefan has the ability to make it available to any reviewer. So if the ISG wants that as part of the package, we can easily arrange to have those specs, those normative references available for.
I think that would be a great idea, because I'm trying to get us out in front of this, because when this happens, any AD could ask for those references. So
Roman, should we take an action item to mail you a copy of the SCIP document and Sarkar as well? Is that the request?
This is
I'm
Murray.
sure Mike
not
can
Nolan.
take care of that.
Roman is not in the room. This is Murray, your AD, not Roman,
Okay, sorry.
the AD that holds the discuss. So the other thing that came up is there was I don't know where there was an expectation that a document be available within the hour. I didn't see any chatter like that on the list. If you'd like to point that to me, like maybe that happened out of band where I didn't see it, but it's just that if we don't have the reference, we can't proceed with our review. It's not that you need to give it to me within an hour.
It's out of band.
Spencer?
Email exchange.
Action item clarified.
Right. Yeah,
Murray,
because I mean, the documents they're based out of Europe. They're in the Netherlands, so it's a 6-hour time difference. So take that into consideration as well.
so how about this for an action item? If Murray, if you can provide a list of people who would wish to have the document to the authors, they will make sure that those individuals get it. Is that a fair summary, Mike? Dan?
Yes, I think, and again, that the email address is provided right in the document for those to request the document directly from NATO.
You could get this request from a directorate review, not an area director. Like if a sector reviewer looks at this and says, there's a security reference here I can't get. Now you have the problem before it even got to the ISG. So I would encourage you to be proactive about this, not wait for someone to ask for them.
Excuse me, be proactive in what way?
Yeah, you need the email address of the people who need it, at least, right?
Yeah.
Yeah, I mean, let's the concept is you send the email to them and they will provide it to you. Now, their judgment may turn to us to ask whether or not you need this document, but we have only seen a few such requests, and that was early on. Before I leave that topic of availability of document, long before this ever left the AVT group, I'll test some people's knowledge, those that have been through this process. There was a gentleman on here that my memory represented Cisco, had a screen name of Fluffy, who basically looked at the document and basically looked at the draft and said, everything I need is in here to implement this. He didn't even need what's in that reference as a skip 210. And that's true.
Spencer?
Spencer Dawkins. Making documents process faster enthusiast. I observed that everyone in line behind me, including me, is either a current or former area director. So one of the things I wanted to emphasize is that the ISG, for every session I've been around for, is on a roughly 2-week cycle to review the next set of documents. This is why they're not running out ahead trying to get ready for the next telechat or the one after that. It seems to me like it would be a good thing for the ISG to consider adding something to the Shepherd write-up for the document that says, are the references freely available on the website? And if they are not, where do reviewers, including the ISG, where do they reach out to get copies of the references so that they could do the review? I think I have not been involved in the process with this document at all, but other than just watching it in here, but it seems like to me that would have gone a long way to helping everyone focus on asking early. And if the answer is there's a person that you can contact, as it was with Stefan with the AVC documents, if there's a person you could contact, this is the person. And that it seems like to me that rather than trying to design something ad hoc for this document or for art documents, other places in the IETF will have the same problem, and it may be helpful to just add one line to the Shepherd write-up that says this would be a good thing to add so that things can slide through more quickly. Thank you.
So I just looked up a few things about my older RFCs. I have probably like something like 15 RFCs to my name. The vast majority include informative references to documents that are not available on the web. The vast majority. This could be academic publications, conference publications. It could be white papers, sometimes from industry consortia where you don't even get to, even if you ask them potentially. These are all informative references. There was never a problem with it. I have a feeling either you guys in the ISG are getting, more diligent by the minute, or this is something which has to do that there is the word NATO or whatever in the picture, which or I don't know. Yeah, this is. I mean, clearly, the situation from my viewpoint has gotten worse over time here. And I hope this can be corrected. Thank you.
Magnus Westlund, former AVT Core Share and Transport AD. I think there's a couple of things here that's clearly the working group, the document shepherd and the working group chairs can help in the situation. I think write-up is a good idea. Pinging, telling the responsible AD that, yes, this is something you need to tell. I do note that there's one area where this is going to remain a problem, I think, is the review teams. They are very poor at reading the actual write-ups, and they don't get it in their face. I actually wonder if we actually need to do something about the error review team tool in the data tracker to actually make this a bit more clear towards the reviewers that, hey, this is the actual write-up part, so they can look at it more easily. But yeah, but this has been remaining a problem, I think, over the last 20 years for some document that at some point someone has objections against, especially normative reference not being easily available. But yeah, I think it's a matter of work with the process here to trying to inform ahead of time that you might have to request this, etc., to get it, and there will be much less problems from the review teams and ISG.
I think our order is split.
That could work.
So to Spencer's point, I think that the most recent version of the Shepherd write-up, which is less than a year old, actually does include have you made sure that all these things are reachable by anyone who might want to review the document. I think that's there. If it's not, I can certainly make sure that they add it. To the point about the variability of what the ISG reviews and its diligence, I mean, when you point a different bunch of ADs, you get a different level. I mean, that's going to fluctuate with every ISG. There's not a bar that we try to hit. But this issue in particular has come up enough times that the RFCs around downrefs and stuff like that, now there's a proposed change to add, if you have an external reference, here are the, I don't know, rules or guidelines around when you should do it. Here, if an external reference that you want to make that's normative is completely inaccessible, here's what you should do to make it accessible. And there's a process we're talking about for doing that. So this isn't the first document that's happened in my time on the ISG. So we are talking about solutions to this.
Hey, Lucas Pardew. I am not on the ISG. I do sit on some directorates. I do not have a stake in this draft, but the internet stakes are increasing, and getting good reviews is super important. And it's not just the ISG, it's not just the directorate, it's the last call that goes to the IETF. People are willing to do reviews, but don't necessarily have the time to carve out to do these things. You might say, I'll dedicate an afternoon to look at this draft. And the turnaround time, something like this, I don't want to pick on this one, but it's just an example where I won't be able to do it, and I'll just move on and do something else. And that hurts the quality of our documents. And this isn't just a problem here. I sit on review boards for other things outside the IETF, and they prepare review packages to make sure that I can do the job that I would like to do and that they would like me to do. So I'm sure there's other things we can do within the IETF to improve this, and I'd really encourage us to do it. Not just this group, but whoever might need to be involved along the lines of what Murray was saying or Magnus was suggesting. So thank you.
Okay, Mike?
Sorry, I want. Sorry, a little trouble with the microphone. I wanted to point out that Skip 210, which is referenced, seems to be the reference document that people are referring to, which is in our draft RFC, has been referenced before in another IETF draft RFC that was approved about 2 years ago. So it's not like this hasn't happened before in exactly the same way that this is. Dan, do you remember, what was the RFC on, number on TSV CIS?
8817.
So,
Skip is actually a normative reference in that document, and it's kind of related to comments coming up further. So
yeah, when we'll get to those, and really it is similar in what it's looking for, which is basically a payload type declared for TSV CIS with a sampling rate in it to make it through a connection. So it looks a lot like ours. And going back further, if you want to look at RFC 4440, which I believe is a great reference for it. That's an old document, but it declares a payload type for transmissions between ISDN and IP, and doesn't really talk at all about what the RTP payload that's in there. Thank you.
All right, so we are out of time for this segment. Had some good comments. I had said he would watch the recording, so hopefully we'll be able to get in touch with him and clear the.
Is there any conclusion for the records? Packages, create packages.
Oh yeah, good. In general, create, yes, good. I mean, where it seems like it's useful to reviewers, try to include any references, that aren't publicly available is sort of the general practice going forward. But for the specific thing, the blocking thing at this point is the heads discussed. So he promised to record, or to watch the recording of this once the once his whatever his family issues are resolved, and so hopefully we can get that resolved.
Right. Yeah. I mean, it's important
Back to the
back to
EBC document, Stefan, can you send me an email by which the ISG can request copies of the EBC, so we don't go through this for EBC as well?
Sure, I can do this.
Yeah, so I guess the only other thing.
So I have another comment, but the discussion is closed, so I will leave that for some later time. Thank you.
All right.
Yeah, the only other thing I could suggest, Mike, is, well, we should talk offline, but somehow some clarification of what you put on these slides might be helpful, just so everyone understands what the process is. But hopefully, through what we described, anyone who wants the document will get it, and at least that will be cleared up.
Okay, we can do that. And again, I guess we can discuss with Roman via email the response to his concerns, which are the next couple of slides. That I guess if we don't have time.
I mean, Roman said Roman is no longer a discuss, so he said we can. He's at this point.
No, he abstained, but I mean, he actually put a comment in about 2 hours ago, additional comments. Whether they affect what's going forward or not, I don't know.
It shouldn't, no.
Okay.
Okay. All right, well, thank you.
Yep.
All right. Okay, so next up is RTP over quick and Mathis.
Hello. All right. Yeah, next slide, please. So we made a couple of updates since the last interim meeting, and I will go through the most important changes today and then give a few overview or a little overview of what we are currently doing. Next slide, please. Okay, so these are pull requests that we merged since we had the last meeting in May. I will go through a few details of the stop sending later. The first 197 is just a little reference that we changed. Then stop sending will be more slides later. Green metadata is added to the RTCP considerations that we had already, but it's just a little note that adds green metadata to the list of RTCP messages that we considered, just to have that documented that we considered it, but we don't think there's anything that that Quick can help to replace this message or something like that. The same thing for RTP header extensions. We added a list of header extensions similar to the list of RTCP packets that we already had. But for all of them, we basically just say that we considered them, but there's nothing that Quick can do to replace them or something like that. We noted that the purpose of some of these header extensions is similar to what Quick could also provide, but there's no one-on-one replacement that Quick could provide. Then we added a list of optional extensions to have an overview of all the Quick extensions that are listed in our draft, because we have a few different places in our draft where we references different quick extensions. And we thought it might be helpful to have an overview in the end in an appendix to see which are the ones that could potentially be useful for RTP over QUIC. Then 102 is some considerations about aggregating frames in QUIC. So this is talking about QUIC frames, not media frames. And it basically adds some information about what you have to consider when you pack datagram frames for media. Murray, you have a all right. Okay. So when we pack datagram frames, media packets or RTP packets and datagram frames, and we always use the full full MTU, and it might happen that QUIC has to send multiple extra packets for acknowledgements, for example. And we added some considerations for that, for example, if you have smaller RTP packets, then it might be possible to send less QUIC packets because you can put the egg frames in the same QUIC packets. Then 105 added Spencer as a co-author. We have been working together for about a year or so, and now Spencer is finally officially a co-author on this draft. 106 is again change for stop sending, but we will talk about that in more detail a bit later. The same for closed stream and enough frame, which are currently being, or closed stream is discussed in the QUIC working group, and enough is kind of the equivalent for stop sending for that, but we'll get to that later. And Spencer added a motivation section with a couple of points which note why it might be useful to use RTP over QUIC. I won't go into detail for this now, but if you are interested and have a look at this or at the diff, there's a whole new section with different items on it. And then there's another editorial thing where we added some ROQ wording because that wasn't consistent. I think we had different capitalization of the acronym and didn't use the acronym everywhere, and we didn't really introduce it properly, so that's changed now. Next slide, please. So we're currently working on error codes pull request, and later I will have a list of other open issues that we are planning to work on next. So this is the thing that we are currently working on, but we will, before we go into details for error codes, we will talk about stop sending on the next slide. So we discussed stop sending in a couple of last meetings, I think, and we now made 2 pull requests, which changed the text about that again. And the most important points, I will quickly go through the points that are listed here. So we say that our queue receiver must be prepared to receive RTP packets on any number of QUIC streams, depending on the flow control limits, of course. But it has to be prepared to receive media frames on different QUIC streams. Lucas. All right. Then our queue receiver should not make any assumptions about which RTP sequence numbers are carried in which streams, because we didn't want to reference QUIC stream IDs or something like that. We didn't have that before, but we made it more explicit now that our queue receivers shouldn't make any assumptions about the QUIC stream IDs. And specifically, our queue senders may or may not continue to send RTP packets on lower stream IDs, even though they already used a higher stream ID after that. And then we explicitly say that our queue senders may use reset stream to cancel frames, and on the other way, receivers may use stop sending to request canceling media frames. And now Lucas wants to ask a question.
Hey, Lucas Pardew. Can you hear me? Yeah? Okay, yeah. Cool. Just a clarification on those 2 points. Those 2 make sense in complete isolation, but when the receiver sends the stop sending, the sender must reset that stream.
Yes.
And is that in your conceptual model?
Yes.
Okay.
I think it's also mentioned in the draft that if the sender receives stop sending from the receiver, then it has to behave as QUIC RFC 9000 specifies.
That's great. Thank you.
All right. Next slide, please. So our queue sender that receives stop sending for the last open stream that is available for sending RTP or RTCP data must open a new QUIC stream to continue sending new media frames. So that basically says that if all the other QUIC streams are already closed and the sender doesn't have any other quick streams currently open, it has to open a new one because the stop sending is not intended as a message to say, stop sending me this media stream completely. So the receiver still wants to continue receiving media on that RTP stream, but to make that possible, the sender has to continue sending on new quick streams. And yeah, the word stream is unfortunately a bit overloaded here. That's why I try to make it clear that there are RTP streams should continue to go on, but the quick stream should be closed as specified by RFD 9000, and then the sender has to open a new quick stream to continue sending the RTP stream. Bernard. Bernard?
I think we'll get into this in the next presentation, but I've always had this question about what's in signaling. In other words, do you think you need to negotiate streams versus datagrams in signaling? Because this receiver is kind of sitting there, and I guess it could receive RTP frames over datagrams or streams or some mixture. So just a question, when you stop sending, is there like an expectation that it'll open a new stream, or could it start sending datagrams? I guess you have to be prepared for anything, right?
Yes, that's a good question. We have an issue on that, on does the sender use datagrams or streams or whatever. Here in this part, we made it, or tried to make it clear first that the sender has to continue sending the media stream, because the stop sending is not intended to stop the media stream, but instead to stop the quick stream. And we have an issue for considerations about is some signaling needed to negotiate whether they're using datagrams or streams or a mixture of both. Yeah, for this part, we said that the media stream has to continue. And if currently the draft doesn't say anything about what the sender has to do. And I can just say, I do quick streams or datagrams or mix them. And we may add some restrictions on that. We have this issue for that, but the draft currently doesn't say anything about it. Spencer, are you getting in queue or? Sure.
He's replacing the.
Awesome. Spencer Dawkins. Thank you, thank you, Lucas, for your comments, and thank you, Bernard, for your comment. For Bernard, one of the things that is going on is we are trying to write generalized text based on things that are true and quick now, without perfect knowledge of knowing how quick will evolve in the future. And so some of these things there may be new extensions that are more helpful, like you've got close stream and things like that on the slide here. Yeah, we're shooting at a target that is not moving as fast as quick used to, but it does move fairly quickly. Thank you.
Yeah, I did have one other question about closed stream, which is, do you envisage that being used by RTP over quick implementations? Because at least for partial reliability, it seems like reset makes more sense. Or where do you think closed stream would come in?
Yeah, I was getting to that with the last 3 notes on the slides, I think. So when a sender receives stop sending, we discussed in Yokohama, I think, that there's the problem that it needs to continue sending the media stream, but it should not continue sending it on the same stream, of course, or on the same quick stream, of course, but it should also not send the same frames that the receiver tries to cancel on a different quick stream. So we changed the wording for that, but there's still the case that could happen that the sender receives stop sending, but it does not know at which point the receiver sent this stop sending. And so at some point it has to cut off and start a new quick stream. And since there's no way to signal where to stop and where to continue sending the media stream on a new quick stream, the sender just has to, or what we currently say in the draft is that it has to start continuing from the first media frame that has not been sent on the quick stream before, even though that may not be the same that the receiver thought it was. And you want to?
Yeah, so I guess my question is this something you envision as actually being useful to do as an RTP receiver, or are we just saying this is a feature of Quick, so we have to specify how it's handled, but it isn't actually very useful, so you probably don't want to do it?
The second one, I think. So I think we have to say something about it, what happens when stop sending or reset stream is used, but and then since we specify it may be used, but I don't know if it will be super useful or not. So, but I think we have to specify something. Lucas.
Hey, Lucas Pardew. I think I might jump the gun. I had a question about closed stream. So if we're not there yet, I can wait.
Yeah, then wait a minute, maybe. Thanks. So yeah, okay. The receiver can still accidentally cancel media frames because it cannot say where it wants to stop, and the sender does not know where the receiver wanted to stop. So the sender just continues sending on a new quick stream after the last frame that it previously transmitted on the earlier quick stream. And now to closed stream. I think closed stream may be useful in the case where the sender sends, for example, 2 media frames and there are a couple of losses in the second frame. So the sender wants to finish the first frame but does not want to finish the second one and then continue with the third frame on a new quick stream. In that case, we try to cancel the second media frame on the first quick stream, but still want to reliably finish the first media frame on the first quick stream. And in that case, I think it may be helpful to have closed stream, but I don't know how often that will happen because you have these losses on the second media frame, and if you at that point already decide that the second media frame is not very useful anymore, then you probably also don't need to finish sending the first one anymore. So in that case, it could be helpful, but I don't know how practically it will be in real implementations or in use. Yeah. So Lucas.
Yeah, Lucas Pardew back. Related to the last comment I made, if you want to use closed stream, but then you have the peer send you a stop sending and you must send a reset stream, then you can't send a closed stream that you would have liked to use. I think, I don't know if this is a design on purpose in the spec. We have the spec, or one of the spec authors of closed stream here. Maybe we're low on time. Maybe we can have a chat afterwards, because I wonder if.
Yeah, that's a good point. I haven't thought about what happens when the receiver sends stop sending, and then the sender can probably not use closed stream. It has to use reset stream.
That's what I don't know. So I think we should.
Yeah, we should talk about that. That's a good point. And yeah, then there's this enough frame for which I don't know if it will be ever finished or if there will be work being done on that, because as I said, I don't know how useful closed stream will be. So it may not be the most useful thing to have enough in the first place. But if there are use cases for that, then maybe. So we have a note on that in the draft currently, which says you can close stream to use to avoid this loss in the first frame. But as I said, it may not be useful because if you already in the second frame, you probably don't want to finish the first one anymore. And yeah, I think that's it. So yeah, Spencer. Spencer?
Nope, mic's not on.
The microphone is off.
I'll say something and then we can work with it later. What's being described here is kind of a fundamental question for this working group, which is the level of maturity that this working group wants out of the underlying specifications, especially from the quick working group. When York and Mattis started work on this draft, it was kind of, here's base quick, the RC 9000 series of specifications, and then we had a datagram, and we're starting to dig a little deeper into drafts that are not approved for publication, but they are decently mature. So now we're talking about a couple of drafts that are, I think, closed stream existed in some form but was renamed before this IETF meeting. If I got that right?
Yeah.
Oh, okay, people behind me who are smarter are saying yes. So that's still kind of the next level of aggressiveness as far as reflecting quick documents in this specification. So the authors will try to do the right thing, whatever that is.
Right, next in the queue is Altanai. Who's that? Okay. Can you make sure the mic's working and you're on mic? No, to talk to.
Maybe use the
use
one back.
Okay, hi, I'm Altanai from Cisco Meraki. In the spec, I can see a lot of topologies out of scope, but considering a topology between an SFU and multiple endpoints, some streams may have like silent data like noise or white noise kind of things, and other streams may carry real data. The document doesn't mention anything prioritizing the actual data from the the white noise data. Is there a plan to add that?
I'm not sure I understand the question. Is this related to stop sending closed stream things, or
No.
then maybe can we take this offline afterwards?
Okay.
All right. So
Martin Seemann, Protocol Labs. I'm one of the editors of the closed stream draft. So to answer Spencer's question, yes, it was called Reliable Reset Stream, and we renamed the frame to closed stream. It is currently not clear what to do in response to stop sending. So if it's not clear, then RFC 9000 applies. But I think we can change it to make it a valid response to also send a closed stream frame. One comment on the maturity of this document. The Web Transport Working Group has decided to take this as a dependency. So while it's still going through the process, there's other customers for this work. I'm not sure if there's a use case for enough, if that would justify moving that draft along, or maybe merging that with the closed stream draft. We should probably talk about that afterwards.
yeah, that's a good idea. So the comment about the maturity was definitely about the enough one. I know that the closed stream seems proceeding. So yeah, we should talk about whether that should be merged or there's a use case for enough. Then, yep.
Someone is turning off these mics.
No, I think you need to be right on axis with it, I think.
Harald Alderström.
There you are.
That is very on axis.
Mm-hmm.
I'm nervous about bullet 2 on your slide. I mean, consider the case where I send frames A, B, and C, where I get A and B out, and then I get the stop sending. But C, and the stop sending was sent because he didn't want A anymore. But C depends on B. How can I tell whether or not I should resend B? I already sent it, but it crossed on the Y with the stop sending.
Yeah, so I don't think we can have any signal at the sender side which frame was the one that the receiver tried to cancel. And so I don't know how or what else we can say except for continue from where you think you stopped on that first quick stream.
This makes me nervous. I would like to have someone who understands exactly what you're trying to do and reassure me that I shouldn't worry.
Okay, yeah, sure. we can definitely talk more about that. I think maybe, if I understand you correctly, you're worried that there are dependencies between the frames on the first quick stream, and I just can't, or just stop sending after one of them, and then I don't send one which is, or on which other frames depend. And I'm not sure if it would be, or maybe it would be useful to add some sentences about dependencies between these frames and where exactly to continue on the new quick stream. But I'm not sure how to make that applicable for all different kinds of codecs or payload formats.
Unfortunately, we're over time for this presentation, so can you just go very quickly through?
Okay, can I quickly finish the error?
Yeah, just want to talk quickly about the error codes. But
okay, so we have a couple of error codes, and we talked about. Can we go back to some slides? Yeah. So we talked about the error codes before in previous meetings, and we removed one currently, which is general error, because we thought it may not be helpful, because we have an internal error which says something at the internal implementation failed, and we have a packet error which says something I received from the peer broke something. I discussed with Lucas earlier this week, and he said it may still be useful to have this general error, so we might add it back. And this is currently work in progress, because there are a couple of more comments from Lucas which we didn't address in the pull request yet. We have to set up a IANA registry for assigning error codes, and we actually have to assign proper error codes, but we're working on that. And yeah, so if you have any questions about the error codes, then please also approach us afterwards. And then we have a list of currently open issues, but I think a couple of them will be addressed in the next presentations, especially about NUT traversal and ICE. And the next one, multiplexing, is actually also kind of related to the peer-to-peer quick draft, I think. Then 75 is probably the one that we are going to work on next. That's about multi-hop topology considerations for RTCP replacements. And then there are a few more open issues. I don't want to go into detail. And, yeah, if there are any questions, then please approach us afterwards. And yeah, and I think that's it.
Okay, great, thank you.
Thanks.
And Peter, you're up next. And unfortunately, we're a little behind schedule. So Peter, if you want to have time for your S-frame presentation also, we can try to.
Nothing to report regarding this draft, correct?
No, nothing to record for
Thank you.
RTPR quick, other than the authors will continue to work on it. Sorry, yes, not only thing to, there's nothing to, no action items other than the author team continues to work on their open issues. Peter?
Can you hear me?
Yes.
Test? Okay. All right. So previously I talked about peer-to-peer quick I think at the last AVTCORE meeting. And I think it's something that other drafts or documents could reference. I'm thinking in particular about W3C documents that would allow for a peer-to-peer quick API that then ROC could be built in a web app. But ROC could also reference it, and it might make sense for it to be coordinated with the work Martin is doing that he's going to present on later, and perhaps even mock. There's been some talk about peer-to-peer mock. So basically, somewhere we should write down how to do ICE and quick together that can be used for all these things. So that's what I did. Next slide. So things in the draft include ALPN value, how to demux, what kind of things are needed for signaling or negotiation, certificate verification, in particular for client certs, and then the cluster of things related to multipath network migration and connection IDs. Next slide. The details are that I picked an ALPN value of Q to Q. The demux between ICE and quick is done with the stun magic cookie. Things that need to be negotiated include the ICE parameters and candidates, the role, the quick certificate fingerprints, whether or not to use a grease bit, and then whether or not to use this thing I'm calling a multiplexing ID. I'll have a slide on that in a second. The client certificate must be verified, and quick multipath should not be used, and quick migration should not be used. ICE can handle the quick migration, and multipath doesn't. I don't know if it doesn't make sense, but it's much more complicated for peer-to-peer than it is for client-server. So I put a should not, but it can be used if you know that the connection's actually client-server, even though this is for peer-to-peer, because you can have a peer-to-peer client-server connection. I I did put in something about using quick pings instead of ice in the place of ice checks, which kind of overlaps with something that Martin has in his draft in mode 3. I'll get to that in a slide in a second. And then network migration in this draft is done by us, not quick. And so the connection ID shouldn't change, because from the perspective of quick, it's like a virtual socket where the path doesn't change.
Lucas?
Lucas Pardue, just a clarifying question here on the first note, the ALPN Q to Q. I didn't really get to read the draft in fine detail, but what is the application layer here?
What do you mean by the application layer?
ALPN stands for Application Layer Protocol. All I'm seeing on that page is a list of transport configuration. So that doesn't align with the layering modeling. It's fine to do, don't get me wrong, but effectively this is a profile of Quick, a version of Quick or something. It's not an application protocol, because otherwise if you do try to define it that way, and now you want to do an application on the top of it, like RTP over Quick, it's not. It's RTP over Quick, or Q to Q over Quick. It's the layering conceptualization. And that kind of concerns me if it's the right pitch.
Well, I think if we're going to provide a web API and allow applications to do, say, ROC on top of a peer-to-peer quick web API, I don't think we're going to be able to have the web app pick the AOPN. So I think this is kind of the only direction we could do. However, if that's wrong of me to think that we can't have a web app pick the AOPN, perhaps it doesn't need to be specified. But Bernard might have a comment related to this. Maybe that's why.
Yeah. Web transport example has a single ALPN regardless of what application runs on top of it. So this
and
is
web transport is an application layer protocol. So I don't want to like.
The same API could be used for either one of these, so it looks exactly the same in the browser, whether it's Q2Q or web transport. They're analogous. It's the same as quick. This is essentially the same as quick transport, which also had one ALPN.
I disagree. I don't want to faceplant on it, but it doesn't work that way. And I think we can fix it. So let's take it offline.
Yeah, so I didn't mean to like get into detailed discussion of all of these things. This is more like letting you know what's in the draft, because we've only got 10 minutes less than that now. So this is more like intro, so we can decide whether we want to adopt this or not.
Hi, RuPaul Apple. Just one small question about migration there. What exactly do you mean by turning off quick migration? Because the quick stack is basically required to validate a new IP address. Are you just saying that that will be done by ICE?
Yes.
Okay.
Okay. Next slide. So one thing that I included in the draft, because there seems to be a need for it, but could theoretically be kind of a separate draft because it's orthogonal, is the idea that is presented in the quick datagram document, which says, okay, if you want to be able to multiplex your datagrams with different purposes, you could put a varant in the front. And so basically I said, okay, for different purposes for the same quick peer-to-peer connection, we could do the same thing both for datagrams and stream IDs. And the reason for this is you typically don't want to have more than one peer-to-peer connection. You want to make one connection and then you do everything on top of it. So for example, if you're doing mock or rock peer-to-peer, and you also want to have some control data on the side, let's say you're doing exchange of trickle ICE candidates, then you want to be able to multiplex those things. So one option is to take that approach that was mentioned in that quick datagram document and say, we're going to put an optional var int in the front. We need a name for this thing. I called it multiplexing ID. And you can have it negotiated. So if you don't want to do this, you don't have to waste the byte, or more than one byte maybe. But if you do want it, then you can negotiate it. So that's an option that's in the draft also. Next slide. I also included some SDP. It's kind of straightforward. I don't know if we need SDP, but everyone always wants it, so I put it in there. The ICE and the ICE things are exactly the same as in WebRTC. The DTLS, the quick fingerprint and role are exactly the same as the DTS fingerprint and role as in WebRTC. The same attributes, just now applied to quick. The only thing that's kind of quick specific, you see at the bottom in bold, is that we need to pick some values for the strings there. So I put UDP/quick and m=application. And then if we want to allow the negotiation of options like quick extensions or the grease bit, then we have an equals line for that. And lastly, the mid can be used both for putting this M line into a bundle group in case you want to bundle RTP with, regular RTP, not ROC, with quick, and also for specifying the multiplexing ID that I mentioned earlier. So next slide.
No, Bernard, did you have a comment?
Oh, sorry, Bernard.
Yeah, I had a question about this STP. I'm a little bit confused by it. I think I understand the M-equal application. That's basically generic peer-to-peer quick that anything could run over like data. But the other one, the quick RTP AVPF stuff, that's a little confusing to me because does this mean quick streams, quick datagrams, some mixture of the above? And are these separate quick connections from the data one, or are they all bundled together?
Yeah. Oh, I'm sorry. Yeah, I guess in this example, I put in the ROC ones. I don't remember if I meant to do that or if I was just, if that was intended to be the old-fashioned RTP.
Yeah, so I'm just wondering, so it's bundled together, so it's all on one quick connection, is that right? And some RTP stuff and some generic data.
Yeah, so what I was thinking was this is the regular RTP, but you could do ROC in this way where this would be using the multiplexing ID to multiplex within quick, not between different quick connections.
So the MID here is referring to the multiplexing ID, so it would have a mid of one in front of, okay. So basically, I guess what you're saying here is it's got this mid in front of it, and it could be datagrams, it could be streams, but basically ROC looks at this and says mid one corresponds to this M-equal audio line, I guess. Is that right?
Yeah, so theoretically, we could choose to use the multiplexing ID in ROC to multiplex different things, like this, where you say, okay, the audio is multiplexing ID 1 and the video is multiplexing ID 2. That's not critical to the spec here, but that's an option.
So the mid here, you do mean the MID, RTP, SDES thing and RTP header extension, not your multiplexing. Okay.
No, I mean, if the string here is UDP/quick, it would mean the multiplexing ID I'm defining in this draft, not the RTP header extension. But if that's too confusing, we could just pick a different string instead of A=MID.
This is Spencer Dawkins. Are you ready for me?
Yeah.
Sure.
Okay, so my opinion is only one of the ROC draft authors is that, yes, we could use this for ROC, but the multiplexing capability that we're talking about is, am I getting this right, Peter, that it is basically, this is what you do for, I'm sorry, that this is what you do for peer-to-peer quick?
This is an option for peer-to-peer quick.
Using that multiplexing that you described on the previous slide?
Yes, I'm saying that as a part of peer-to-peer quick, we can optionally have this variant prefix as a demux point.
So the way it was looking to me as you were talking about this slide and the next slide was that a lot of what I liked about the way you were headed was that the application didn't have to make a lot of adjustments to be running in either peer-to-peer or client-server mode. But if you have a capability that's useful for peer-to-peer, it might be useful to think about it for client-server, because we're defining a multiplexing ID in ROC, and if that was defined someplace else and was used, okay, if that was not part of peer-to-peer quick, but was used the same way, same way for peer-to-peer and client-server, doesn't matter whether you're doing peer-to-peer or not. That might be useful, and that could be in the ROC draft so that it is. That could be in the ROC draft so that it is available for both. The question is whether it should be somewhere else so that it might be useful for other applications that are using Quick and want to do the same kind, want to do the same kind of multiplexing and don't want to have to write their own from scratch. You had mock with a question mark, so maybe it needs to be in a separate draft so that it would be easier for different kinds of specialized quick transport media transports to use. Thank you.
Thank you. Martin?
I share Lucas's confusion.
Closer to the mic, please.
I share Lucas' confusion about what you're trying to specify here, because on the one hand, peer-to-peer quick makes it sound like this is a transport thing, but then defining the ALPN, defining how to do certificate verification, and defining an SDP makes it look like you're thinking about a pretty specific application protocol that you want to layer on top. I'm also confused by the multiplexing ID that you're defining. I mean, Quick is already a multiplex transport, right? You have different streams. So it seems like what you want to do is have different groups of streams running on top of the same Quick connection, which is a very similar problem that the Web Transport Working Group ran into by when they tried to have multiple Web Transport sessions share the same underlying Quick connection.
Yeah, so to answer the first question about transport, yes, what I'm defining here is a transport, not an application. And the reason for the ALPN question is what I already mentioned, but we can, as previously suggested, take that offline. And then on the question of the multiplexing, yes, we want different groups of streams. And yes, Web Transport does have a way that it does that. And one of the reasons, as I put on the bottom of the slide, that option was considered. One of the reasons I didn't go with that is because, as mentioned by earlier, I forgot who, it might make sense to have this be applicable for client server also. And so what I would like is for this multiplexing ID to be able to work on top of Web Transport. And if we used the Web Transport mechanism to do it, then we'd have two conflicting purposes for the Web Transport frames.
Okay, Magnus Westlund. I think you need to separate this. One thing is to establish Quick in peer-to-peer transport as a transport. That's one thing. And then there's another aspect of here, which is the application on top. Your multiplexing layer is part of an application. I would claim that you should have different ALPNs for just pure RTP over Quick. And maybe you have another ALPN for WebRTC, which combines data channel and RTP. And you might do a third, which is this multiplexing layer for whatever you're trying to do for a particular purpose. But you're going to have to evaluate so you can run things together on the application on top of the Quick. So separate these things apart. Do one for transport, one for the applications on top of Quick. And this will be much, much easier, I think.
Lucas Pardy speaking. Yeah, I second a lot of what's said here. I put it in the chat too. I think, I'm not against what's trying to be achieved here, but there are similar efforts happening around effectively pooling or a session layer on top of Quick as a transport feature of Quick is something we've heard here and there that's maybe interesting. I don't want, so I'll be blunt, I don't think this room has the precise skills and constituency to develop a session layer for Quick on its own, and that this is maybe not the right venue, even if we can benefit from it. And so, there's things here that this room absolutely can do great. And separation will make this a lot clearer, and I think like smooth the journey for us all. Cheers.
All right, do you want to go on, Peter? That one, yeah. Peter? Did we lose Peter?
Can you hear me now?
Yes.
Okay, so on the question, sorry, I got auto muted somehow. On the question of venue, I have a slide coming up with questions for you. But first, just wanted to compare briefly with what Martin is going to present. I don't want to go into detail because he's going to present it. I just wanted to point out that he's got 3 modes. The first mode is basically ICE plus Quick, which is basically what I'm trying to do here. His second mode is kind of an optimization on that using a relay connection first. And then his third mode, I think we could call it ICE over Quick because it's using Quick packets for ICE checks instead. I did have a little bit of overlap with that since I had a part where I said you could use ping frames. And I'm trying to consider all of this in the context of web APIs. And I think mode 1 and maybe mode 2 could work with a web API, but I'm not sure about mode 3. So that's where we overlap and where we differ. Last slide is coming up. Oh, there's the last slide. Okay, I thought I had a last slide that said next steps. Basically, the question of venue, is this the right place? Maybe it's the right place for half of it, not the other half, from what I've heard. And then, is it a good idea in general to have a separate draft that defines ICE plus Quick that Rock would reference? Or does Rock not want to have anything to reference in this context? So should we continue things here or a portion of it here? Or should we find a different venue?
Let's go on to Martin's presentation. Maybe we can have a general discussion afterwards.
Okay, I was invited to present the draft that I submitted for the Quick Working Group here in this venue. I got 3 minutes at the end of yesterday's session in Quick, and now I have a little bit more time to go into detail. So I'm happy that I don't have to do it in the speed run again. Next slide again. Next slide. So as a quick recap, Quick version 1 assumes that the server is always publicly reachable, and it's only the client that might or might not be behind a NAT. When we speak of NATs, we always have to deal with the fact that there might be a NAT rebinding. So the Quick spec goes into quite a lot of detail how to handle those. Quick version 1 also defines how a client can migrate from one path to another path. For example, if you have a phone and you might be on the Wi-Fi and you can take the Quick connection with you on your cellular interface and preserve all that application state while the packets are now going out over the cellular interface. Next slide, please. Now, with a lot more hand waving, since I don't know a lot about ICE, this is my very basic understanding of how the ICE process works to establish a connection through 1 or 2 NATs when two nodes behind those want to connect. So the first step is that these nodes need to discover their addresses. And in the ICE protocol, stun is used for that, but you also could have like manually curate a list of addresses that you might be reachable at. So at the end of step one, both nodes know like I might be reachable at like this list of 10 addresses. The two agents then establish a connection via a signaling server and exchange these two lists to each other. So at the end of that step, both nodes have a list of the address of the 10 addresses of the other node. ICE then runs a matching algorithm that looks like which of these addresses could be paired to yield a direct connection or a connection between the nodes, and then also runs a ranking algorithm. What ICE does then is it runs connectivity checks, and these connectivity checks basically involve transmitting some packets to the other node, to one of the addresses of the other node, and retransmitting them. And what these packets do is they create NAT bindings on the way, which would then allow packets from the other node to make it through. So basically, that's where the hole punching happens. At the end of this process, if you're lucky, you end up with one or more connections that could be used to establish a direct path between those two nodes. And then ICE defines some logic how to select the optimal path from these candidate pairs. And then once that's done, the application protocol, whatever that might be, can be informed of these addresses and then establish a direct connection. And then ICE can keep the path alive if the application protocol has nothing to send. Next slide. Yeah, there we go. So what's the purpose of this draft? Like this is I want to make it possible to use Quick in a peer-to-peer setting. I'm not thinking about any particular application. So I'm just interested in the building blocks we need at the transport layer to make this work smoothly. Once we have this could be a building block for other protocols that want to run Quick in a peer-to-peer setting. For example, one could use some kind of mapping of WebRTC onto Quick, and this would then work with all the hole punching. But there are lots of other peer-to-peer protocols that could benefit from this work. Next slide. Okay, so my document defines 3 modes, and the question is like, do we really need those 3 modes? But we'll get into that later. So the mode 1 is like the most primitive thing you can do, and I basically just included it for completeness. So what you would do is you first run the ICE procedure as I described it. The ICE procedure tells you like, okay, I've done all the hole punching. Here's a path, use it. And then you just run a quick handshake on that path. This works. This should be very easy. Like this you could probably set this up in like half an hour with existing stacks. There are no changes needed. It also takes a lot of round trips, so there's a lot of potential to optimize this. It also means that we need to run a signaling server. Yes, Niels?
Seems to be working. Niels, just a quick clarification. You're saying that you just run the quick handshake. I would assume that in that case, normally you have on Quick, you have a server side and a client side, and they do not exchange certificates in both directions, or?
And that depends on how you configure your TLS layer. That's not a Quick. That's not a concern for Quick.
but you're dealing with a peer-to-peer connection, so you want to
Yeah, so
enforce.
you probably would use self-signed certificates. You might use client authentication, but that's something that happens at the TLS layer. That's not something that happens at the quick layer. So what I'm saying is, if you're thinking about a specific application, let's take WebRTC as an example, then yes, you would have your self-signed certificate. You would take the certificate hash of that certificate that goes into the SDP, and then your TLS stack would verify that the hash is actually matched.
Okay.
Right. This is like very hand wavy how WebRTC does
Okay.
that.
Yep.
But this is not something that the transport layer needs to be concerned with. This is something that happens at the application layer with the help of TLS. Okay, next slide. So if we go back to the list of what ICE does, is we see that there's in the second step we need to exchange the list of candidates between the peers. So one thing we could do, next slide, is not use a classical signaling server for that, but start with a quick connection that is proxied. So we could use one of the protocols that the mask working group has been defining, for example, connect UDP, but it could also be just a turn server that's forwarding packets. The only thing that we need here is a proxied quick connection, and then we do we exchange the list of addresses inside of that quick connection, and to do that. I've defined a new frame. We called it the ICE frame. The document doesn't go into a lot of detail what you put into the ICE frame, and that's intentional at this point. But of course, that needs to be clarified at some later stage. But for now, the important thing is like we are using a quick frame to exchange the list of addresses between the two nodes. And once that's done, we can use quick connection migration. No, sorry. Getting ahead of myself. This is mode 2. So we exchange the addresses. We give the list of addresses to ICE and run the rest of the ICE procedure. So now ICE will do all the path probing, all the hole punching, will decide for one path. And then at some point, ICE will say like, okay, here I now have a path, and then we use quick's connection migration to migrate the proxied connection to that candidate pair. So the advantage of this mode is that we can use fancy new mask protocols. That's nice. The disadvantage is it's also faster than the first mode, because I'm starting with a proxied quick connection, which means that the application protocol can already start doing its thing while the connection is still proxied, and then just at a later point we switch to the direct connection. But the application protocol doesn't necessarily need to know about this. Yes.
Yeah, it's Omer. Proxy connection to where? Like the connect UDP, you need to tell it to connect to something. Is that still like a signaling server, or is that supposed to be the other peer?
To the other peer.
But that one you haven't punched through the net there yet.
Yeah.
So you would
need to connect to the same server to have the proxy connection.
And then you would have to tell that,
yeah,
that proxy UDP connect proxy thing, basically like wait for both sides to connect, and then
there would need to be some work how to connect these two nodes. Yes.
Yeah, no, totally. You can connect. The client can connect to that quick proxy. I don't know how to call that thing, but like what I'm worried about is that the part is like basically that normally you would tell the connect UDP like connect me to another public thing, Whereas in this case, you would have to tell like wait for the other peer to connect to you as well. Simply, basically turn. In other words, basically, right?
Yeah.
Yeah, there's a slight problem here with this proposal, which is that the ICE connectivity checks, as far as I understand them, use pretty small packets. So the ICE might tell you, yeah, there's a path that works, and then once you try to migrate your Quick connection to that path, it doesn't work because Quick makes sure that the path that you're using supports 1200 an MTU of 1200 bytes. Like that's a requirement for any path that wants to run Quick, is that it needs to have this minimum MTU of 1200 bytes. And it's not really clear what to do if that's not the case for this mode. So let's look at the third mode.
Peter, did you want to say something?
About the size of the ICE packets versus size of other packets. In practice, that's ICE checks being small, but then the media having large packets has never been a problem as far as I know. Like I don't think anyone's run into an issue where ICE gets the NAT bindings open, but then they don't work with packets below 1200 bytes. However, ICE checks being large, if they're quick packets that are 1200 bytes, would be a significant problem for trying to probe the different network paths, because lots of those probes are often sent. And so those being large would greatly reduce the rate at which you could send them, which would make the process of finding a working path take a lot longer.
Yeah, I'm not sure how much of a problem this is in practice, because ICE limits the number of probes that are happening concurrently, because you don't want to create too many NAT bindings at the same time, if I understand correctly. And this at the same time will also limit the data rate.
The rate is still quite high, where if you were sending 1200 bytes per ICE check, that would be around 12 times bigger than ICE checks normally are. And so it would be a big issue for them to increase that much in size. You would have to reduce the rate at which you can send checks quite a bit.
Yeah, I'm not sure if we're currently bandwidth limited on ICE checks, but that's something that would need to be figured out. Yeah. Okay, so then, yeah.
The maximum rate is specified in the RFC is based on an assumption of a certain ICE check size. So if you increased the check size significantly, then that would affect that rate.
Yeah, that's something we can look into. Can I move on to the third mode?
Please.
Okay. So if we take another look at the list, then we can see that there's a few more things that that the Quick layer could do for us. So we already talked about exchanging the candidate pairs, but Quick also allows you to probe new paths. So that would replace the candidate check, the connectivity checks, and then we also don't really need ICE to tell us which path to use if the connectivity checks turn out multiple paths, because any quick stack that does connection migration, and even more so if the quick stack is multipath enabled, will have some logic to decide which out of multiple paths to actually use to send data. So we can just use the logic that the Quick stack already has to select the path. And then Quick already has keep alives as well. So we don't need ICE for that either. Next slide. Yeah, so here's another summary of the proposal. We use a proxy Quick connection for the signaling. We will need to make a small change to what RFC 9000 says, because RFC 9000 says that it's the client that initiates a connection migration. That part is fine. But to create the NAT binding on the server side, we also need the server to send a packet. So the change should be pretty simple as far as I can tell. We could just say that the server can also send a probe packet and could also already put a path challenge frame in the packet. So once these packets make it through, we basically have a path that's verified in both directions. Yes.
Yes, man. One thing you probably want to be careful about is like you start with your proxied connection, and then your probing basically would find a working path. You would migrate, and then later on you might find another working path, and you migrate, and you might find another working path, and you migrate. That's why ICE basically specifies that you have certain criteria for choosing the best path or whatever. So you probably, if you do this, you probably want to replicate some of that logic, saying like, don't migrate immediately as soon as you find something, but like figure out like what's the best path and then choose carefully and migrate only once, because otherwise you get like flickering back and forth between different paths.
Yeah, I mean, this is currently left to quick implementations to decide how to do a path migration logic. Like RFC 9000 doesn't say anything about this, but it certainly makes sense to have some text about that.
Mosinati, is all this still just theoretical, or has some implementation experience been attempted? Because the one thing that makes me worried about using actual quick for the ICE probes is there's a flurry of ICE probes at the beginning. It seems like you may run into initial window issues unless you force the quick stack to ignore the initial window and just let you have unlimited.
Are you talking about the congestion window?
Yes.
Well, the congestion window applies per path, so I'm not running into that limit. I see the problem though. I have deployed some version of P2P quick with hole punching. It's working fine. It's not using the connection migration that I'm describing in this document though.
Peter?
A quick response to Mo about implementation experience. I have experience with mode 1, and that works really well. I think that mode 2 and mode 3 are both very interesting ideas. Mode 2 basically being like do the relay connection first, and there are lots of apps out there that do that with ICE basically, and that also works really well. I think the most interesting thing here is mode 3, and I think it's an interesting path to go down. I on my previous slide was calling it ICE over quick, and I think that is an interesting thing to explore. But and in fact, I have explored it in the past. Theoretically, I haven't tried implementing it. And the problem I ran into was always the size of the initial packets that need to be sent, especially the ones before the handshake. And it's exactly what Mo was saying, which is there are a lot of these that are sent when ICE gets going. And so need them to be small. And if we could
Mm-hmm. All right, we are almost out of time. I mean, we were kind of over time.
I can skip this slide basically. The question is, does this require a quick multipath? And the answer is it probably does not. Things will work more smoothly if you use it, but it should be possible to run all of this within with a stack that just does quick version 1.
Okay.
Yeah.
All right.
I think that's it. Right?
Okay. You had one more slide, I think, Bernard. Yeah. Okay. Just okay. All right.
Yeah,
great.
More for the quick working group.
Okay.
Yeah.
Great. Thank you.
Cool. Thanks.
So yeah, I mean, I feel like this is not exactly in scope here, but because Peter was talking about it, I wanted to do this too. We'll need to figure out where this work is done and how it's done, and I think it sounds like more experimentation is necessary. Otherwise, I guess since we're short on time, Bernard, do you want to go quickly to your presentation? And I did mute you, Bernard. Okay, good. You found that out.
Sure. So this is about HEVC in WebRTC. And just to kind of bring everybody up to date, currently there's support for HEVC decode in web codecs. In Chrome 104, the HEVC hardware decoders are supported behind a flag. So you can try that out. It depends on your hardware, of course. I believe that Safari 17 preview also supports HEVC decode in web codecs. So we're making some progress in getting decode in. I'm not aware of encode support yet. There's also for HEV support in WebRTC, we now have 2 PRs, one for Chromium and one for WebKit. So there's actual code here which will need to be reviewed. And one of the big questions is, what are the tests that go along with this, like the WPT tests, because those require SDP. And so you need kind of an SDP spec, which is what this draft is attempting to do. So as was suggested in the last time we talked about this, I sent a link to this draft to the RTC Web Working Group mailing list. It hasn't been talked about on the list, but I have been talking about it with browser implementers. And they seem to believe that it would be good to have a spec so that these 2 PRs would actually work together and interoperate. They're actually by different authors, which is a whole nother issue. So the big question is, what do we do next?
Do people feel like this would be appropriate and useful to do here? I see some scattered nods. So yeah, it sounds like we should probably, I guess I should do a call for adoption because Bernard is the author. So I'll do a call for adoption on the mailing list and make sure to send that to the RTC Web. And Stefan, make sure to get that in the minutes that I should, might work on. Great. We picked up a little time there. Peter, do you want to do S-Frame now?
Can you hear me again?
Yeah, I hear you.
Okay. Next frame. Next slide. So just a reminder of where we're at. A while ago, I presented on how we can packetize S-Frame, including SPack. I was told to write people to review it. I updated it and uploaded it, and I'm still waiting for people to read it. There seemed to be in all the previous discussions agreement that we should do this and that this was generally a good direction, but we still need to iron out some details. Next slide. A reminder of the general solution. It's to packetize one big RTP packet with some inner codec, like say VP8, and then encrypt that payload using S-Frame, and then packetize that encrypted thing using this S-Frame specific packetization, which is defined in this document, and then copy the headers from the big RTP.
Mo?
So we're working. Yeah, Mozinati. One thing that worried me when I was reading through this is the big packet approach. Seems like a good hack, but some of the payload formats, because they know that they're only going over IP, they have assumptions that the length can only be 64K, so you only have 16-bit lengths. But the media format itself may have huge frames, much bigger than 64K, but because the payload format knows how to dice things small, it's okay with living with 16-bit fields. And the one notable example that came to mind was H.264 STAP aggregation packets. That they have 16-bit lengths embedded in them. So you could not send an H.264 large IDR stacked with its SPS and PPS because you couldn't encode the size of the big RTP packet. So it seems like there may be some challenges with some payload formats that make assumptions that that there's only 64K size, 16-bit lengths for some of these things.
That's good feedback. I had no idea. So I'll have to think about that.
I don't think it's insurmountable. It just starts to get ugly. Like you'd have to specify in a lot more detail that, okay, for this case, you would have to force H.264 to slice the IDR and create multiple steps, multiple IDR slices where every IDR slice is less than 64K. So you could get around it, but it's not the clean, elegant solution that you were hoping for, where you could just, say, hey, codec, go, give me one giant packet, one giant frame, and I'll do all the dicing. You may have to get more, deeper down into the details of each codec and force it to do something hacky to get it to spit out something that conforms to its payload format.
Gotcha.
It's Richard Barnes. So thanks for putting this together, Peter. I think this idea of double packetization is actually useful, and I think could help us get around this the point that Mo raises. I'm personally keen on the double packetization because if you dial down the first packetization and don't encode with an infinite MTU, you can end up with something like the per packet S frame that has been talked about. So you can kind of navigate this S frame, S packet distinction that has been talked about before. So I guess that's a question. Yeah, let me set that aside for a second. If we were clear in this solution that first packetization does not always assume an infinite MTU, but can assume some finite MTU, I think that could get us out of some of the stuff Mo's raising, because if you know that, for example, your you said H.264, whatever, your whatever codec has some limitation that it can't produce, more than 64K units, you could set that as an effective kind of virtual MTU, and that way you'd never overflow. Right. So I think being clear that that first packetization doesn't have to have an infinite MTU could be useful for a couple of reasons, both getting that S packet sort of effect and addressing some of the limitations Mo was talking about.
I could try that.
So Stefan Wenger, I want to amplify what Mo said. The underlying idea, which most RTP formats, payload formats, especially the older ones have, is that an RTP packet is being transported over a single UDP packet, which is 64K in size maximum, right? And I'm pretty sure that beyond H.264 and 3984 aggregation packets and stuff like that, you will find other gremlins that are hanging out there that come and bite you. So this is, if Colin were here, he would probably say something like, "This is not RTP anymore when you're doing this type of thing," right? Thank you.
Yeah, so this is Richard Barnes again. So I wanted to bring up maybe a more controversial point, which is that it seems like we maybe have too much flexibility on the sender side, in that the sender can decide how to packetize each thing independently. Each frame could get broken up in some different scheme. And obviously with the scheme you've defined, like the receiver can reconstruct them, but the receiver has to be prepared to do that. In particular, the case I would like that aligns to the S packet is where the L bit in your framing is always 1, and you never have to do any reconstruction if that's the outer layer. So what I was thinking was it might be useful to nail that flexibility down a little bit and say, that for a given stream, we're always going to use a given, a virtual MTU, say, and signal that in SDP, and so you can have some negotiation around it. So just a suggestion for nailing down some of that flexibility a little bit.
Mozanetti. I think the 64K virtual MTU approach probably could work. It's still a little ugly and not as elegant as I think the original solution was hoping. But I think, like Stefan said, the devil's going to be in the details. You have to just try it and see which payload formats break. And maybe some of them are even already broken. They may not assume 64K. They may assume 8K or jumbo or something, or even 1.5K. So we have to look at the payload formats, and you have to decide what maybe those are useless payload formats, and you don't care about them, and you don't want to carry them forward, and only those more sensible ones you want to carry forward. So I think it'll just be an exercise of actually surveying which formats you care about to S-frame, and whether or not there's devil in the details for each of those formats, and whether this virtual 64K MTU approach could work for them, and whether or not having a frame diced in multiple 64K chunks at an RTP payload format level, and then trying to aggregate that, just concatenation, and then S-frame the whole thing, whether that leads to anything else that's weird, or whether that's okay.
All right, so should I continue?
Yes, but we are over time, so quickly.
Okay. Well, I was basically going to jump to the last slide that we don't have time to discuss details, so, or those details at least. Next steps. Should we do a call for adoption? Should we get more review? What's the next steps?
I see 1 thumbs up. I see 2 thumbs up from relevant people. 3 thumbs up from relevant people. So 4. All right, that sounds like we have since a call for adoption is itself a consensus call, I don't think we really need a consensus call for a consensus call. So yeah.
Just a quick note, like I did review the document. This is heading in the right direction. It needs some clarification on how the things are used and negotiated, but
yeah.
We should.
Okay, yeah. So it sounds like people think it's, obviously it's not done, but it's ready to start being a working group document. Okay, so so note down, Stefan, that we will do a call for adoption on this too. Sounds good. All right, and thank you all very much. See you all the rest of the IETF, and see you in Prague, hopefully. Thank you all very much. Ross.